my name is Donny and today I will be talking about the service repository pattern in TypeScript. There are a few requirements. I expect you to know a bit about TypeScript because later on we will really need it, and I assume you have built a backend before, preferably in an MVC style. What are we going to cover? Well, this is the first video of series. Well, pretty long series actually. We will be going from scratch. We will be looking at an existing project and we will be refactoring that one into a 3-layered project with the service repositories pattern, which will make an application more scalable and easier to manage later on. In this PowerPoint presentation, we will quickly look at repositories, services, an example of an HTTP controller, and I should also note that at the end of this video, I will be giving you exercises which are driven by tests. And with this, I actually mean that you will get a project. This project has a bunch of tests, but no actual code implementation. So it's on you to figure out what the tests are telling you and how to get the service repository pattern working. So why the service repository pattern? There are a lot of reasons. I decided to go with those 3. The first one would be splitting logic. So for example, let's say we have a controller, a HTTP controller, and inside our method we have a bit of logic, right? It's creating a to-do, for example, and it has to add something to it, blah blah blah. All works fine. Okay, so now some other dude comes along and he's like, well, I want to add this feature, and you're like, yeah, sure. But then when you go into your code, you realize that the logic inside your controller method has to be duplicated. In this case, you don't feel like abstracting it, so you know what, just copy paste and it works. Okay, cool. So imagine this happens like 3 or 4 times and you have like 4 places with the same code, and now you need to refactor that little bit of logic because something has changed. So the big issue is you need to make sure that you cover all 4 places and then pray that you didn't break anything or didn't forget to update anything. So the service, mainly the service, will cover this for us because the service will contain the logic. There's a better testing experience because we have more abstractions, which means we can mock and stop certain things. And in my opinion, it scales better for larger projects beyond CRUD, so create, read, update, delete. It's not 100% true, of course, but I think it's fine for most projects that an average developer does. So, the repository. I have a small snippet here of a dummy project of mine where I refactored a project. As you can see here, we have a subscribers repository, and the repository gets a mongoose model, which is called a subscribers model. This model has a bunch of methods to make queries to the database, and if you look at our method, public async get all subscribers, you can see that we are calling a find method on the given subscribers model. So in a nutshell, this repository is a extra abstraction between our service and our database. So you have your service, database, repository, and it is making sure that we are not doing any direct queries inside our service. Next up is actually service. As you can see here, we are, if I can find my mouse, there we go. We expect a subscribers repository, and in our constructor we are injecting it. So we got our subrepository, subscribers repository. So this service has a method called getAllSubscribers, and as you can see here, it's making use of our repository. It's getting all the subscribers, puts it in a variable, and we return it. The subscribers mapper is just making sure that we send the proper data back to our controller. So in a nutshell, the service does all the logic, the repository does all the data handling. The service relies on the repository doesn't rely on the service. To finish this example, this is a simple HTTP controller. As you can see, same thing as we did with the service, it's getting a service instead of a repository. We inject it and we set it. And then we have a method called index. So let's say someone makes a request to your website. Then we want to get all the subscribers. So we call subscriber service, get all subscribers, and then we send a JSON response. And that's pretty much the gist of it. So let's get started with the actual code example. Okay, so to give you an idea of how the theory works in code, I'm going to be live coding a quick example. I would recommend to not follow along because I will be giving you exercises after this, so just watch and learn. I generated a simple project which gives me TypeScript support, and I created a file which pretty much contains a fake database. It's being exported as a singleton, and it has one method called create, and this create method will allow us to add to-dos. This is the interface of the to-do, and everything else doesn't really matter to us. We could also use a real database, but the nice thing is that we can just change to a real database after we are done with this. Okay, to get started, I've mentioned before in the PowerPoint that the repository should be the first thing to worry about. So let's create a class. Call it to-do repository. This to-do repository needs to have access to the actual database. It could be a Mongoose model, a type or a RAM entity, it could be the actual database. For example, if you use Knex, then it could also be the Knex client. But in this case, we have a fake database, so we're going to be adding that one. So now it has access to the database, and what we want to do is create a to-do. So let's make a function, or method rather, which is called save, and this is going to be getting some data, right? What do we want to create? We want to create a to-do, and if we create a to-do, we need to send the title and maybe the completed, but I would say just a title, right? So if we so let's give it an argument, title, and give it the proper type. And now in here we could do this.db and then create. And what does it expect? It expects to do data. And then my dog started barking. Always fun. Which we pass the title and a completed or false. And we return this. I am not sure if I made this async, that doesn't really matter. And then just export this. And now let's get started with the service. So let's create the service. If you remember, the service relies on the repository, so we need to be injecting stuff. So let's make our constructor. And give it access to the to-do repo, and it also expects a type. Okay, so now it's injected. This to-do service needs to have a method that we can call from anywhere. So in this case, let's call it create to-do. Also async. And this one is going to get some data too, because, well, we need data to create our to-do, right? In this case, we can do the same thing. And then we just literally call our to-do repo, save title. And what we could also add some logic or validation in here. So we could say if the title.length is less or equal than, or just less than 6, then we can throw an error. Title has to have at least 6 characters. Otherwise, we create our to-do and we return it. I'm not sure if the database returns us something. It does not, so let's just return true. I don't care about anything else. Or do we return the actual to-do? Nah, just return true. Okay, so this is our repository service pattern. And now let's see if we can use it, right? So let's do const repository equals new to-do repository. This to-do repository doesn't require anything. Let's create our service. And this to-do service, if I can type, requires the... Hey, Vim, leave me alone. It requires the repository. Yes, I know I did an illegal key move. I can't find my cursor, there it is. And now the service can create a to-do. So let's do create to-do and call it my first awesome to-do item. Save. Let's run it. Nothing happens because we still need to log it. So let's do then console.log. There we go. And it returns us true. So it has been created in the database. But what if we create a to-do with like 4 characters? To-do. What happens? It throws us an error. Error title has to have at least 6 characters. Okay, so this all works. So as you can see right now, we didn't even do anything web related, right? So we could even test this or use it with some other application. Maybe you want a console application. So next up, to complete this example, we could do class to-dos controller. This to-dos controller also needs to get the instance of the service, so private read only to-do service, which is being injected now. Let's say we have a method called store. In an Express app you would have request response, but we don't have it right now, so I'm just gonna say request data. Give it a type of any, because I can't be asked to actually type this. And then we just do return this .to-do service, create to-do, request data. Now we could actually type it to string. And now, if you create a new controller, we give it the service. Let's move back up. Move it here. And we can say controller.store an awesome to-do from our HTTP controller. Save. If you look at this, we need to return it again. Done. And if we run it, you'll see that it tells us that it's true, so it has to be saved. So to quickly recap, we create a to-do repository. Do note, a to-do repository, or just a repository in general, is connected to a database. So if we wanted to use Mongoose, you either change this to-do repository, or you create a new to-do repository of Mongoose, right? So to-do repository Mongoose, or whatever, in that sense. So in this repository, we get access to a database. We have a method called save, which creates a to-do. In our service, we get access to our repository. Then we have a method called create to-do. This create to-do has some logic. It checks if the title is larger than 6 characters. Otherwise, it throws an error. And if everything is fine, then we return the response of our to-do repository. Bear in mind, in an actual application here, we could actually map it to some valid data. So let's say this repository would be returning us our to-do. Maybe we want to give it an ID and title as response. So we could do that in here. In our to-dos controller, we have access to our to-do service and a method called async store. And inside here, we call our service, and it does pretty much this. So this is all really nice, but what if for some reason we wanted to use this method inside another controller? Well, then we could have this controller. Let's say this is a to-dos users controller, and inside this users controller we do the same thing, and then we could do const users controller equals new users controller, which gets the same service, and then we could just do users controller .store. This is from the user. Oh, wrong button. And then we should see through twice. If I keep forgetting this, I guess I just hate promises. And as you can see, we're getting through twice. So we use this in 2 different controllers, same logic and everything. I hope this makes a little bit more sense. So now let's get into your actual exercise. Okay, so to get started with your assignment, this is public repository, which you can clone. I will leave a link in the description. If you go to code, there's a link. You open your terminal and you do git clone and paste the link. You should do it in the directory you wanted to clone. But I already did that. So I've opened my editor and I'm gonna quickly explain you how this works. And then I will leave you up to it, and then you can come back later to see how I solved this. So go to your package.json. You can see there are 4 scripts: test repository, test source, test controller, test final. You should do them in this order. So you do yarn test repository, and then you go to source user repository, and you start doing what the test is telling you. Do note, there's a note which is saying make DB public instead of private. So every property that we are going to be assigning to our classes has to be public, but in a production application it has to be either private or protected, most likely private. The reason we are doing this is to make sure that I can do testing. So if you run it, yarn test, what was it again? Repository. Then it should be telling you something when it finally runs. It is getting somewhere. There we go. It's saying 4 tests failed. If you scroll all the way to the top, you can see your steps. You do all of them. When they're green, you move on to the next one. So good luck to you, and when you're done, come back and then you can see how I've done it. Alright, welcome back. I hope it was an easy assignment, and if you want to follow along, then feel free to follow along. Otherwise, just close the video and be done with it. Okay, so I'm going to go quickly through this. The test is telling me that we need a database connection, so I am assuming that it wants me to create this. Save it. Let's see if it's happy. Yeah, it's green. So next step should have a method called createUser. Ooh, async createUser. And I would also assume that createUser expects some data, right? So let's say user data, which is going to be user request DTO. To get a reference, this is a user request DTO. So we expect a username and save it. Okay, second one is done. Third one should call the create method on a database when invoking the create user method on the user repository. So when we call user repository create user, the db create method should be called. So to me it would also make sense that we return to data. So we say user data, save. And now it's completely happy because we did also do the for test, which returns the user. Okay, next step is test. Oh, doesn't like me. What is it doing? Yarn test service. So let's go to our service. And as you'll probably see, it's just repeating. It's not as hard as it sounds, at least. So it should have access to the user repository, because the service depends on the user repository, right? But the only thing that's different is that we need to inject it through our constructor. So public user repo equals user repository. The reason I call it user repo is because the test expects the user repo. If you're not sure what the test is expecting, then you can go to the .spec file and it will tell you. Okay, save. We did our first step. Second step should have a method called createUser. Alright, so I would assume that it also expects data. User request, DTO. And I would also assume that it wants me to call the user repo. So let's just stop doing this. Return this.user repo, createUser, user data. As you can see, it's telling me same thing like we did in the repository, and also return it. So this should fix both tests. It's interesting how long those tests take. Okay, it's done. So the next step would be yarn test controller, because that's the last bit to connect everything. So let's go to our user controller. And this one, if it ever comes up, also needs to have something injected. And in this case, it's going to be the user service. So we pass it to user service, save. Hey, we have access to our user service. So it should have a method called store, should make a call to user service created user, should return a user with the name John Doe. So we are going to create our store method, which also gets some data, and we'll call it request data. And an Express framework, it would be request, and then we would access RESTlet data to get the actual data. So this is going to be of type user request DTO, and then we return this.user service.create user request data, which should get, which should solve all those tests for us. Unless I miss it. I didn't. Okay. So that's all done. And the final step is to go to bootstrap.ts. And in here we need to make our composite route. So test final. This one is real simple. We just connect everything and then it should be working. So I'm not going to wait on the test. I'm just going to say user repo equals new user repository. We have a user service, new user service, which relies on the user repo, and we have a user controller equals new user controller, which gets the user service. And we need to export this one because the test requires it. So if you save it, then the test should be happy. And this was pretty much the entire assignment. If you want to look more further into this, then I would suggest using a real database instead of the fake one, and setting up an Express server to actually see how this all works in a real application.